I'm going to give you about a 1.5 to 2.
Out of a 5?
Right. So in other words, it's not bad. And then there's some little parasite in this red blood cell, however.
Which one?
Right here.
Oh, really? So that's a parasite.
Mm-hmm.
How can you tell?
Because it's an organism in the red blood cell, it looks more like a protozoa rather than a bacterial organism. So again, it may be something called babesia, or possibly protomyxoa sticking. It's larger than most babesia are, but there are different species of babesia, and one is really small called Babesia microti, and other ones are a little bit larger. There are about 20 different species of babesia. Considering your international travel, it could be any number of things like that. So look around, see what else we see.
That's only a 1.5 to 2 out of 5, because they definitely look stick together. Oh, those ones that are nearly on top of each other you're referring to.
Yes, right, this. Okay. So 1.5 to 2,
Good, I thought it would be like a 4. I'm very happy about this.
Well, let's look around. I always evaluate it on the best place, okay? If I go over here a little bit more, then that's what we see.
How
right?
come?
So
how come there is so bad?
Well, because this is a tendency for the cells to want to stick together, and as the blood moves out toward as it floats out toward the outside, when you put the cover slip on it, then that tendency is aggravated as you move to the exterior of the sample. So I always evaluate it in terms of that objective, that number, based on the best right here. Okay, so in other words, I couldn't find any place in your sample where the cells look like this.
Right. How many people do you see who have cells like that?
Healthy people.
But people come here?
Yeah, well, a lot of times I'll get a wife is ill and then she wants me to check out her husband or something like that, and so then I see them. Basically, the healthier people there's a very strong correlation between the degree of rouleaux and the degree of health challenges that people have.
Yeah.
And because so much about our health has to do with what's going on in our GI tract.
Yeah.
And whether we have bacterial overgrowth, yeast overgrowth, which then, or parasitic organisms and gluten sensitivity, anything that can be causing small bowel inflammation, then allows for this leaky gut. When you have undigested food getting into the blood, then it opens Pandora's box of all kinds of other things that can occur. It stresses out the adrenal gland. The adrenal gland has to puts out extra cortisol. Then that eventually can cause an imbalance in the adrenal function or adrenal fatigue.
Do I have undigested food and blood?
Well, that's what this is suggestive of.
Okay.
In other words, a leaky gut is allowing undigested proteins to get into the blood. Many of these proteins are sticky. They're asymmetric. That means they have a negative charge on one side and a positive charge on the other, and they cancel out this is what's called zeta potential of these cells to repel each other. So then the cells come together. These are proteins that are called lectin proteins, and so gluten is a huge lectin protein, so is dairy, so is soy. A lot of beans are high in lectins, a lot of grains are high in lectins, even corn, even though it's got its own kind of gluten that isn't considered to be a problem for people with celiac or traditionally gluten sensitive people. Okay, now fibrin is forming, so that was at 17 after. All right.
Oh, fibrin started at 17. 17 minutes?
It's 7 minutes since I took your blood sample.
Fibrin started at 7 minutes.
It's so it formed at 7 minutes after taking your blood sample. That's these little lines back here. Okay. That's part of your blood clotting mechanism. There's a protein that's normally dissolved in the blood, and the liver produces an enzyme called prothombrin, and it controls the rate at which that turns from a dissolved form to an insoluble form. It should ideally take at least 20 minutes before we see that. So the faster it forms, the more prothombrin you have, and that's associated with liver stress.
Yeah.
That doesn't mean your liver isn't working. It means it's overworking. It has too much to do.
Yep.
And so in revving up like that, it also produces too much of the prothrombin, and then that can cause the excessive production of this fibrin.
Yep.
Now, certain enzymes, like proteolytic enzymes, will break that down.
Yeah, I need to take that.
Right. And of course, this is a big issue in people with fibromyalgia, because the fibrin, not only is it forming excessively fast, but it's actually forming even before the blood gets out of the body. So it can be forming systemically inappropriately, and then it can coat the blood vessel walls. It can get into muscle tissues, and then that reduces the oxygen delivery to the cells.
What's that?
That's called an echinocyte, and the membrane on that cell is oxidized. Now, that can be a normal part of cell death, because as these cells die, then they become weak, they lose their glutathione, and then they have the oxidative stress causes the fats in the membrane to oxidize. Now, this one is an echinocyte also, but you can see how fine and thin those little like pin needle things are there. And that one looks like a fairly healthy cell.
Are we looking at red blood cells now?
Yes, these are red blood cells, correct.
All of them.
Now over here are platelets. All right, and that platelets have activated, which is typical once they're out of the body. They splat, and then they look like that. But these, okay, so this cell I'm a little concerned about, because this one, all right, because you can see the interior of the cell, the hemoglobin is very messed up in it. It's not uniform like it is on these. And the points on this echinocyte are much bigger and broader at the base than in what is typical of a healthy red blood cell that is naturally dying. So I'm suspicious that this cell is infected with something.
Some kind of bacteria.
Yeah, it's probably some kind of bacteria. And these are the kinds of cells that I often see spirochetes exiting from. When the cells, the spirochetes, if you're carrying any tick-borne spirochetes or even something like syphilis, or there are even some oral spirochetes that live in the mouth that can get into the blood, especially in situations of infection, dental infections or periodontal disease. So if I see these spirochetes, I don't know exactly, if they're from a tick, if they're from sexually transmitted disease like syphilis, or if they are dental spirochetes. But you shouldn't have any of them there. And there is finally some research that's being done on dental oral spirochetes that's suggesting that these, when they get into the body, are causing health problems. They're associating them with cardiovascular disease because they cause inflammation in the blood vessels, and there's probably eventually they're going to associate them with other kinds of chronic illness too. Now, anyway, this even though I was most concerned about this one because it doesn't look healthy, you can see in this cell, you see that little thing wiggling out of the point there?
Yeah, what is that?
Right. Well, that looks like a spirochete trying to come out of that cell.
Would it be trying to get out now because the blood is dying?
Well,
That soon?
yes, exactly.
That soon?
Well, normally it takes about 45 minutes to trigger all the cells to die. But these cells only live 120 days. And so they undergo natural cell death. And and every 120 days approximately. And at that point, if there was a spirochete living in that cell, then it would have to come out.
We just happen to be seeing
And
a
we
cell
can-
at the end of its cycle.
Exactly, and
Okay.
and then it looks like we see an organism emerging from it, right? And,
What are these moving things?
well, those are the triglycerides.
Oh.
Now, this one may not be a triglyceride. It could be, it's large enough that it may be a small bacterium, but you can't tell. Definitely these little tiny ones are the triglycerides dancing around. And they dance around because of something called Brownian motion, if you've ever remember back from science class.
I have very high triglycerides.
You mean your doctor said that?
Yeah, my blood test.
Oh, okay.
Some of them look deformed.
Well, okay, they're like this right here.
Yeah.
Right. They are now deforming because this fibrin that has formed. That's a net, like a three-dimensional net now that's in between the cover slip and the slide. And so as these cells want to drift, they're very pliable and flexible, and they kind of, they want to move, but they're protruding through this fibrin net, and it's distorting their shape like that.
Okay. That doesn't mean it's an unhealthy
No,
cell.
no.
It just means it's being
No, not at
distorted.
all. Okay. All right, so this really doesn't look like a triglyceride. That may be a bleb form of a spirochete, as well as this thing too.
What did you mean, a bleed form of a spirochete?
Well, okay, these spirochetes have all these different morphological forms. This is a drawing.
different stages.
Right. This is typical, although they don't really have, you can't see the spiral shape that much unless you stain the sample, okay? But they're long and thin, and they have a very subtle spiral shape. Okay, then they can morph, so to speak, and they can lose their cell wall that keeps them in this shape, and when they do that, then they blob out. They get a little fatter and lighter in appearance. If we see those, I'll point them out. And then they can, just because they don't have a girdle keeping them in this shape, they can morph into just a myriad of different shapes.
And we're seeing something like this,
But
aren't
this
we?
is right. But this is kind of what I just saw, which is, either potentially what's called a cell wall deficient form, or the spirochetes can actually break up into little almost spore-like segments, and sometimes we can see that it looks like a chain of pearls, and then these little spore-like pieces clip off, and then these are called granules or blebs. Okay, so each one of those has a potential to grow back into a spirochete. Some of them are so small, they're the size of triglycerides, okay? Some of them are a little bit larger, like the one I just showed you. This is a target cell, and so is that one. And that's also, that's caused by liver stress or low iron, and it has to do with how much cholesterol is packed into the red blood cell when the blood cell is being made. So the liver controls an enzyme that regulates how much cholesterol is put in there. It does not have anything to do with serum cholesterol. If you get your cholesterol checked by the doctor, they're checking the cholesterol dissolved out here in the serum. This is completely different. But it's reflective of either liver stress or low iron. Now, but then usually if you have low iron, I see smaller than normal red blood cells. And I'm really not... Your cells tend to be a little on the smaller side, but not enough to call them a microcyte, which is one that's indicative of iron deficiency. All right, so here we have another cell where we can see a spirochete wiggling out. You see that?
Oh, so you're sure it's a spirochete?
Well, it looks like a spirochete.
Uh-huh.
Right.
So, is it safe to say at this point that Amanda has Lyme's disease?
No. I can't say she's got Lyme disease, okay, because it's a spirochete. Lyme is Borrelia burgdorferi, is a specific genus and species of a type of spirochete. There are many other species of Borrelias that are found in ticks they've associated illness with at least 3 other ones, but probably they have different degrees of pathogenic activity in the body. Borrelia burgdorferi is probably the most pathogenic, in other words, most likely to cause illness.
What's that thing?
Okay, well, that looks like a spirochete form, just a little heftier one, okay? Different species of spirochetes have different breadths, different widths to them. And the Borrelia burgdorferi one is broad like this one. Can I say that this is Borrelia burgdorferi? No, I can't. It does.
How am I to know if I have that
Borrelia burgdorferi? Well, let's see. We're going to look at your IGeneX test because there are fingerprint bands that are associated with the surface coat of Borrelia burgdorferi.
Do you think indeterminate means a positive?
Yes.
Okay.
In other words, your immune system is making a little bit of antibody to that specific protein. And in the case of band 41, it's just a flagellar protein. Well, if band 41 is positive, then you have spirochetes. Doesn't necessarily say you have Borrelia burgdorferi, but you have spirochetes. So again, the medical community is just focused on, do you have Borrelia burgdorferi? They should be focused on tick-borne infection across the board, not...
He's trying to make a home.
Well, he's out there in the serum. Things aren't going well for him because the blood level, or the oxygen level, is decreasing rapidly. It's also very hot because I got this microscope tensor lamp down here, so the temperature in the environment is going up higher than it should. So,
forgot about that. It's actually real. I mean, this is actually happening right now.
Right.
Cynthia, this is really incredible.
Well, I'm always amazed at how looking at the blood helps us to figure out things.
So what happens to that spirochete that in the serum?
Well, he's going to die. He's not going to, if he's not healthy, then he's probably not going to try to get into another cell at this point. I see them coming out of cells. They have, like I've just showed you, they seem to be able to detect when the environment inside the cell is not conducive to their optimum survival, and then that's when they will bore their way back out. So as these cells are dying, then because they're out of the body now, then we're likely going to see a lot more of them if you have a high degree of infection. We don't even know that looking at the blood can be quantitative in some way. For example, these organisms get in any cell of the body. So if I see a certain, let's say I count 10 of them in our hour worth of observation, can that make a statement about the degree of infection in the rest of the body? We don't know that. However, I do know from looking at hundreds of people with Lyme disease and are under various kinds of treatment for Lyme disease, I see a correlation as they are on treatment and the treatment is effective and their symptoms go down, then the number of organisms that I see in the serum go down also.
Fantastic.
And when people get down to less than 5 or less, in an hour's worth of observation, at that point they usually have no symptoms. In other words, their bacterial load is low enough that whatever toxins they're producing are probably at a level that the liver can process out. It's more the toxins produced by the organism that is causing the symptoms of the organism than the organism itself. The immune system's reaction to the toxins. And if that is very inflammatory, almost like an allergic reaction, then people have a lot of pain and inflammation and burning. If that immune response is not that inflammatory, then they have less symptoms. But sometimes I'll see, I stop counting at 50 and in an hour, and I'll just say the number is greater than 50, and when people have that many of organisms showing up in the serum at the 1 hour point, they have a lot of symptoms. Here we have a couple things that are interesting. Okay, these look like cyst-like structures here. Okay, these spirochetes, that's another thing that they can produce. They can form a cyst, which is like a little hibernating shell, and they curl up into it, and then they stay there for a while, probably until the environment has improved, and then they hatch out, the environment for their survival, which is, in other words, your biological terrain is going down, or antibiotics you're on are then withdrawn. And so they form these cysts to protect themselves and to hibernate. They're not very metabolically active. Here's pictures of them, okay? So I'm talking about these structures, maybe this one right here. They're almost, they don't produce much toxin. Yeah, possibly that one. Definitely these two look like spirochete cysts. There you can see, this is in dark field. That's another kind of microscopy that sometimes you use. That's what they look like. This is, what they look like in phase contrast, just that this isn't as sharp as an image. But here you can see it with an electron microscope what they do. This is, they pull themselves into this cyst.
Oh my God.
Okay, and you can see the coiled spirochete inside the cyst. And that's what makes the light and dark spots in there. So then, in the cyst, they stay there for a while, but before they hatch out, they usually multiply. So they go through some kind of a reproductive cycle when they perceive that the situation is right, and then they hatch out. So when they hatch out, there's not one spirochete coming out, there's 8 to 12 spirochetes coming out of these things. And so I have images of the cyst hatching too.
The more cysts a patient has, would that also be an indicator that their body's more chronic? That the infection is more chronic.
Correct. I do agree with that, and especially if somebody starts developing biofilm. That's another way they have of avoiding the immune system and avoiding antibiotics, is that they'll secrete this gooey mucus kind of stuff around them. And actually, other kinds of bacteria can get into this biofilm with them, and yeast can get into the biofilm with them. And they now know that all kinds of different genera of bacteria and organisms in the body have a way of communicating with each other. It's called quorum communication. And so they however, we don't want to think of these things as having a consciousness, but however they have evolved, they are able to communicate and develop these biofilms together as a cooperative thing. So as they do that, then they're all protected in there, and I guess by joining together, they can produce better biofilm. And so the biofilm can be spirochetes in the biofilm, it can be cyst in the biofilm, it can be cell wall deficient forms in the biofilm. They're different depending on what kinds of, or what stages of the organisms are in there. The biofilms can look different in many different ways. This is one that has some spirochetes hanging off of it. This is another kind of a loose biofilm. This one is Borrelia burgdorferi with mostly cystic and some spiral forms around the edges. This is one that has the cell wall deficient forms and granular forms in it. So I can see various different kinds of these biofilms. But your question was, Lee, was, okay, is this, how can you tell a chronic infection?
Yeah.
And that's one way that, if you see biofilm, that's been there for a while. I don't know what organism this is. I've seen this before, but
the little
black one right here, right? It kind of looks like a little protozoan, but okay. So now here we have what looks like one of these little biofilm structures. Okay,
This
right
one?
there. With spirochetes hanging off of it. See that?
Oh, right, yeah. Is it safe to say, though, that even in somebody who you would say, quote, consider a, quote, healthy person, they're still going to have a certain amount of these spirochetes or the bacteria floating around in there? It's more to do with the number, the quantity, how long, the duration. Is that what you're saying? So everybody's going to have some element of bacteria.
Correct. Now, that's true about bacteria in general. However, the spirochetes are a little different from that. You should not have spirochetes. If you do, then you likely have some kind of dental issue where they're getting, periodontal disease or infected root canals or whatever, and they're getting into the blood from that. Or you've picked up tick-borne spirochetes, or like I said, another one is syphilis. So probably all spirochetes in the body are parasites. Parasites are not good for you. They take your nutrition and they produce their waste products, and their waste products have a degree of toxicity. They don't want to kill you, so they're not true pathogens in the sense of like typhoid or something like that, right? They don't want to kill you, they just want a host to live in. And so they can compromise your health, but very rarely do they actually kill their host. Now, there are reports of people dying from Lyme disease, but it's probably not just an infection of Borrelia burgdorferi. They probably have a lot of other complicating issues and co-infections too, that is weakening their system even more.
Right, okay.
Now, over here, this looks like a spirochete, or a cystic, the shell. I don't think there's actually a spirochete in here. It looks like a cyst shell, in other words, was a cyst, but it's empty now.
What's that mess?
Well, this is a lovely little cell that we want to see actually a few more of. Can you pull up your blood work? Do you have a low white blood cell count?
Yeah, I do.
Okay, because this is the first one I have seen. This is a neutrophil. Okay, neutrophil is a kind of white blood cell that actually has movement, has mobility. You can see it kind of gliding through the sample like this, and it works like an amoeba and will engulf. They're called phagocytes. They engulf bacteria and viruses and take them in, and then these little black dots are packages of enzymes that destroy the organisms.
Yeah, I have a low.
I mean, I know you have a low CD57, but that's a lymphocyte. Okay. Well, all I can tell you is that I'm not a doctor, so I can't diagnose anything, but a lot of doctors who are in the Lyme world would interpret that as a positive for Lyme disease. For
Lyme.
For Borrelia burgdorferi, in fact.
Because of the band?
Yes, because of the bands, right. Now, these little bubbles that are showing up here are little CO2 bubbles from yeast-like organisms. So this is another thing that I score from 1 to 5, depending on how much of it you have. Ideally, you don't want to see any yeast in the blood, right? It's just in the systemic. It's getting across the gut barrier into the blood.
So that's just leaky gut?
Yes. It's associated with, number one, leaky gut, but the yeast can actually trigger leaky gut in the first place, because when they go into this mycelial form, which is a thread-like form, and they can actually grow through the gut wall and get into the blood. So, but it's associated with gut dysbiosis for sure, but also with a suppressed immune system. Because once they're in the blood, then your immune system should wipe them out pretty readily. And if it's not keeping up with the yeast load coming in, well, then we see these little bubbles. This is not the yeast organism. The bubbles are not the yeast organism. They're the CO2 bubbles of the, just like when you're baking bread. So as it sits here in the warm microscope slide, we see these bubbles get bigger and bigger and bigger because they're carrying out respiration, and then we see those. The yeast themselves are probably in this like biofilmy goo right here. But anyway, so there's a fair amount of yeast here. Here's another little spirochete in there. A little short one. Okay, so here's another red blood cell that looks like it has a parasitic protozoa-like organism in there. But we haven't seen very many of those.
What is it doing in there? Will it try to break out of there?
Well, that kind of a parasite, when it's ready to come out, will cause the cell to lyse, to break open. And that actually can cause low red blood cell counts, because then your blood cells are popping before they should. And then the bone marrow has to keep trying to make more, but so anyway, I haven't seen what I like to see to be confident of it being babesia. Anyway, so here's another one.
Babesia is what?
Babesia is a little protozoan co-infection, right? And here's a picture of it from the CDC. Okay, so it has this elongated form, like what we potentially saw there. It has this ring form. Okay, and then when it's in this ring form stage, that's what I like to see to be pretty confident that it is babesia, because this thing moves around inside the red blood cell when you're looking at a live blood sample. So this elongated form that we just saw, or we saw that other one that looked like a curved, kind of a C form, that might be one of these that was just curved a little bit more. So, and we haven't seen a lot of it. So if you did pick up babesia along the way, I think your immune system is keeping it under control.